enzymes. Enzymes are highly selective catalysts that greatly accelerate the rate of reactions. So they speed up how quickly a reaction takes place. Most enzymes are proteins, but some catalytic RNA molecules have been discovered. So there are RNA molecules that will catalyze reactions and help speed them up in the same way that these proteins will, and so they both work as enzymes. In enzymatic reactions, the molecules at the beginning of the process are known as substrates. During the reaction, these substrates are turned into different molecules known as products. And at the end of the reaction, the enzyme will be unchanged. The enzyme may have to change shape a little bit to bind to the substrate and finish the reaction, but the enzyme itself will be unchanged. It will not have turned into different products. It will not have gotten bigger or smaller. It will remain unchanged. Enzymes work by lowering the activation energy of a reaction, drastically reducing the reaction time. If you had to build up all that energy to complete a reaction normally, it would take a really long time. Well, whenever the enzyme works on a reaction, it lowers the activation energy and makes the reaction happen a lot faster. In fact, a lot of our metabolic processes would not be fast enough to sustain life without enzymes there to speed up the reactions. Enzymes are highly specific for their substrates. That means that each enzyme will only bind with specific substrates that fit with its active site. So each enzyme has an active site. Here we've got our enzyme. To give you an example, this area would be the active site. So both here and here, this open area in the overall shape of the enzyme is the active site, and each enzyme has an active site, and only substrates with a similar shape that would be able to fit in there and bind without the enzyme changing shape too much will be able to fit with that enzyme and complete a reaction. So this would be your substrate. And this is where the substrate would be coming into contact with the enzyme. Here you can see the enzyme and substrate have bonded, and now they have formed the enzyme-substrate complex. And you can see that the enzyme changed shape a little bit to bind to that substrate. And then in this next phase, you have the enzyme product complex, where the substrate has started to turn into two different molecules and separate from each other. And then in this last part, you've got your enzyme remaining unchanged, and the products, two separate molecules that the substrate has been turned into, will leave the enzyme. So you can see the enzyme remained unchanged, and the substrate was turned into two separate products. And going through this stage is going to lower the activation energy of a reaction. Enzymes can be affected by inhibitors, which are molecules that decrease enzyme activity, and they can be affected by activators, which are molecules that increase enzyme activity. So where you have enzymes that are raising the rate of speed of a reaction or lowering the activation energy needed, the inhibitors are going to slow that process down, and the activators are going to speed that process up. So where the enzyme is acting on a chemical reaction, these other molecules can also interfere with the chemical reaction and either speed it up or slow it down. The main thing to remember about enzymes is that these are highly selective catalysts, and they are going to increase the rate of a reaction by lowering the activation energy needed, and at the end they are going to remain unchanged.